Yes, before everyone join, let us have a quick recap or let's recall what are the topics we have discussed in the previous class. So we were learning about the satellite orbits. So the satellite orbits are classified as LEO, that is low Earth orbit satellites, medium Earth orbit satellites, MEO, GEO, and MOLNIA, and high altitude platforms. So this is one such representation of the satellite orbit. Okay, so let's get started with the further topics and let's move ahead. Okay, so this is about the small video which we have seen in the last class about how the satellites are orbiting in their orbital planes. Okay, then based on the services provided by the satellites, these satellites are also classified as fixed service satellites, that is point-to-point communication. So it will be designed specifically only for particular purpose. So that those satellites are called to be fixed service satellites, FSS. Okay, and there will be point-to-point communication between the two Earth stations or two satellites. And the second type is based on the services. It is classified as broadcast service satellites. That is for broadcast, which means that one to many. So there will be one source, and they will be broadcasting the information or any kind of signal to the others, to the other receivers. So best examples are the satellite television and your radio communication. Okay, and also we have the direct broadcast services, DBS services, as well as we have the third category is mobile service satellites, that is mobile service satellites, MSS, which provide the satellite phones. So we get satellite phones and we get communicated with each and everyone. Okay, so apart from this, this broadcast satellites services, that is radio, which provide radio communication. Well, we all know that. Have you seen an app? Okay, so there are all the radio stations are being broadcast with the help of the satellite communication. Probably in the next class, I think most of you would have seen that. But in the next class, let me show how this broadcast service satellites services are providing a service for the radio broadcast signals. That is, at any moment, if you click that particular, like a globe kind of app is being created, and when you click a particular location on that globe, what happens? It will be able to hear the radio services provided at that location with the latitude, longitude information as well as the time information in their regional language. So I'll show you in the next class. Okay. Next, we'll move ahead with the further topics. That is the sub-satellite point. So now we have launched the satellite and it is being placed in the orbit for its rotation and for its the purpose. Okay, purpose of communication. So we need to understand certain points, how to locate the satellite and how to get communicated or how to interpret the satellite which is being placed in the orbit. So for that, we need to have some basic information. The first one is the sub-satellite point. So the location of the satellite is generally specified in terms of the latitude, longitude information, which is going to be just a small point on the Earth. Okay, so with the help of the latitude, longitude information only, we are able to locate the satellite. So this satellite location is specified by a point on the surface of the Earth directly below the satellite. So the location is identified in such a way that a point is being located with the help of the latitude, longitude information from on the Earth's surface, which is the line directly from the satellite. Okay, that is directly below the satellite. So this point is known as the sub-satellite point, SSP. It is known as the sub-satellite point, which gives the location of the satellite. So that is represented in terms of the latitude and longitude information on the Earth's surface. So this sub-satellite point is then located by the conventional latitude and longitude designations, which means that you have to represent this SSP in terms of latitude and longitude information on the Earth's surface. So this is how we locate the position of the satellite, okay, which is placed in the orbit, okay. And next, once we are finding the satellite, we should keep a track how the satellite is moving in which direction it is moving, so that we need to have our earth station in order to interpret the or intercept the satellite to receive the information or to transmit the information. So the tracking is being done. How it is done? With the help of this latitude, longitude information only. So this latitude and longitude form a system for locating any of the given point on the surface of the earth that is used widely for the navigational purposes. So with all this, so let we all know that these lines of latitude are drawn on the surface of the earth from east to west, whereas it is parallel to the equator. Latitudes are not always of same circumference, and the center of line of the latitude is called to be the equator. Well, we all know that. Okay, so that is the biggest circumference latitude that is being located on the earth is the equator, which separates the earth into the northern and the southern hemispheres. So the regions which are above the equator are called to be the northern hemisphere, and the regions which are below the equator are called to be the southern hemisphere. Okay, and so this latitude is defined as the angle between the line drawn from the given point on the surface of the earth to the point at the center of the earth, that is called to be the geocenter, and the line between the geocenter and the equator. So how technically they define the latitude? Well, we all colloquially we tell that latitude is nothing but it is an imaginary line that is drawn around the surface of the earth's curvature for the navigational purposes. We normally tell like that. Okay, but technically speaking, what a latitude means, so it is defined as the angle between the line drawn from the given point on the surface of the earth to the point at the center of the earth, which is called to be the geocenter, and the line between the geocenter and the equator. So that is called to be the latitude information. Well, we all know that the 0 latitude is nothing, 0 degree latitude is the equator, and the 90 degree latitude is going to be either the North Pole or the South Pole. So gradually it will be increasing, the angle will be increasing from 0 to 90 degree. Okay, when we start from equator, when we go forward to the North Pole it will be 90 degree, and all the other latitudes will have the degrees between 0 and 90 degree. Similarly, when we go below the equator, that is from starting from equator towards the southern pole, southern hemisphere, what happens? It will be starting from 0 to, and when we reach the South Pole, it is going to be 90 degree. So remaining all latitudes will have the values 0 to between 0 and 90 degree. Okay, so that is the latitude information. And coming to the longitudinal information, so the line drawn on the surface of the earth between the North Pole and South Poles is generally referred to as the meridians or the longitudes. Okay, so the line drawn from on the surface of the earth from the North Pole to South Poles are called as the meridians. They are normally called as longitudinal information. A special meridian called the prime meridian, which is being used as a reference for all the calculation purposes, even for time purposes. So well, we all know that the Greenwich meridian time, that is going to be the prime meridian. So based on that as a reference only, we calculate our time calculations. Is it not? Day and night for all the countries around, for all the places around the world. Everything is with respect to the Greenwich prime meridian, is it not? So this line on the surface of the earth drawn between the North Pole and the South Pole, which passes the location Greenwich, which is located at England, is called to be the prime meridian. Okay, so this longitude of a given point is the angle between the line connected to the geocenter of the earth to the point where the prime meridian and the equator and the meridian containing the given point of intersect. So now let us see. So based on this information, we need to give the designation as whether it is east towards the east or west. Okay, longitudinal information, we need to do it with respect to the prime meridian as a reference, whether it is eastern side with respect to the prime meridian or it is western side with respect to the prime meridian. East and west destination we need to add to that, apart from the degree, whatever we are mentioning. Whereas in case of latitude, we need to add the information whether it is north or south. Okay, as an example, you see, for locating the Washington DC, it is given by the latitudinal information and longitudinal information of 39 degree north and 77 degree west. Similarly, we can locate our Chennai also. So I wanted you to find what is the longitudinal and latitudinal and longitudinal information for our Chennai, and your place also. You can try to identify the place where you are staying. Okay, try to identify the location. Okay. So this is how it is being located. So you see, this is the Earth and this is the equator, and so this with the half which is above the equator is called to be the northern hemisphere. This is the southern hemisphere. So the latitude, the angle of latitude. First we defined one definition. What is the angle of latitude? Which means it is the line that is drawn from the point on the equator to the geocenter, and the point that is drawn from the geocenter to the location where we need to calculate. So this is the angle of the latitude. So here what happens? It is going to be at the angle 39 degree. Where it is in the northern hemisphere. Therefore 39 degree north. So that degree at the equator here it is 0 degree. Degree at the North Pole it is going to be 90 degree. Whereas the location of the Washington DC it is going to be 39 degree north. So normally this latitude information is calculated in this way. Okay, same way let us find the what is that longitudinal information. So this green color line that is going to be the what is that prime meridian, that is going to be the Greenwich. So that is going to be 0. That is going to be 0. That is going to be the prime meridian. So with respect to this, whether we go from the western direction or in the eastern direction, we need to mention. So Washington DC, it is west of the England country, is it not? It is west of England. So what happened? So the angle between the green prime meridian, that is the Greenwich, this one you see. So this line, the angle between the prime meridian and the location where it is located, this line. Okay, this line, it is going to be the angle of longitude. So the value here it is 77 degree western side of the prime meridian. So this is how any point on the Earth's surface is located and represented. So this northern western thing, we normally tell that as a designation. Do you understand this point? So with this as a reference only, we are going to locate the satellite position, that is going to be the sub-satellite point. Okay, based on this. So we have to place the Earth station in such a way that we are able to locate the satellite and receive the information. So for that purpose, this tracking and navigation by using the latitudinal and longitudinal information is important. Do you understand this point? Do you understand what a latitude is? Sir, can you enable chat box, sir? I have made, sir. 1 second, ma. Hold on for a moment. Yes, sir. Your chat box is enabled. Can you post your responses in the chat box? Is it clear to everyone what a latitude is and what a longitudinal information is? Simply we tell on the globe or the map, whatever we have studied in our geography, simply latitude information, longitude information. Okay, so based on this information only, we are able to locate our GPS is functioning in our mobile app also. How? It is locating the information from the satellite. Kishore Kumar. So if you wanted to share some information, post the messages to everyone so that everyone can have a look at that. Kishore has given the latitudinal and longitudinal information for Chennai. For Chennai, it is going to be 13 degree north. Okay, and longitudinal information, it is going to be 82.27 degree east. We are eastern side of the Greenwich meridian, prime meridian, whereas we are above the equator. Therefore, it is north end. Do you understand? So we are very closer to the equator. We are just 13 degree. Okay. Do you understand this concept? So, is it clear to everyone? Okay, I repeat now. Let me repeat. So it's a general information, but as an electronics engineer, you should know all this basics information. These basics we have studied in our geography also. but still you have to recollect and have it. Even we are in school days, just we have memorized and marked up and we have written the exam. But at this moment, you should clearly understand the concept and learn. So let me talk about the latitude and longitudinal information again. So this is the Earth surface. So this circle is the Earth. It's represented here. And this blue color is the equator. So this equator divides the Earth into the northern hemisphere and the southern hemisphere. Okay, so we calculate the latitude information with respect to the equator. So we assume that we have created that this zero, the equator is going to have the 0 degree. Okay, whereas in the North Pole, it is going to be 90 degree. Whereas in the South Pole, it is going to be 90 degree. So the value of the latitude, it will be varying gradually from 0 to 90 degree when we move across the globe in the northern hemisphere towards the northern hemisphere from the equator. In the same way, when we move from the equator to the southern hemisphere, the southern pole, towards the southern pole, it is going to vary from 0 to 90 degree. Same is the case for everywhere. That is for latitudinal information. And for longitudinal information, we are going to take this prime meridian as a reference. So as we have taken the equator as a reference for latitudinal information, here for longitudinal calculation, which are the lines running from North Pole to South Pole, we are going to take this prime meridian as a reference. Okay, so this we are having it as a reference. So when we have this as a reference, either we have to move western side of the prime meridian or on the eastern side of the prime meridian. In the same way, the degree is going to be, so prime meridian is going to have the degree 0. So it will be varying from 0 degree, 1, 2, 3, etc. And it will be going like this. So what is the final thing? It will be 360. Is it not? 0, 1. So it is a full circle. So as in the latitudinal information, we have divided into the hemispheres. So it is going to be take only a 90 degree in the north or 90 degree in the south. But whereas in the prime meridian, when we move away this direction and the other direction, it is going to be, what is that? 270. The other side, it is going to be. Okay, or if you wanted to reach the same position, it is going to be 360. Okay, so that is the information. So how normally this latitude is calculated? Let us see. So this is the latitudinal information. So which we are moving from equator to the North Pole. So it is going to be the angle that is formed from the point on the location which we wanted to find to the geocenter. That is, this is the location where we wanted to find its latitude information. So we have to draw a line from that point to the geocenter and the imaginary line from the geocenter to the equator. So the angle formed between the two lines is going to locate the latitudinal information of that particular point. So this is the angle of latitude. So what is the angle here? It is going to be 39 degree. But it is in the northern hemisphere. So we represent the designation as 39 degree north. Yan. Okay, in the same way, we wanted to locate the longitudinal information. So it is going to be 0 here in the prime meridian. And we have to draw the imaginary line from that location. So this location, what is this? This location to the geocenter and the prime meridian location to the geocenter. So the angle formed between these two lines is going to be the angle of the longitude. So that is going to be 77 degree for the location Washington DC. So where it is in the western side of the prime meridian. Is it clear? Therefore, it is going to be 77 degree west with respect to the prime meridian. Is it clear? It is 39 degree north with respect to the equator. Is it clear? So this is how we locate any point on the Earth's surface. Okay. In the same way, the other countries which are on the eastern side, like Arabian countries and so a few of the African countries and all the Asian countries, they will be in the eastern side of the prime meridian. Okay, so why we wanted to locate this any surface on the earth with respect to this latitude longitudinal information? We wanted to locate the satellite on this surface which is in the orbit. Why? In order to place the earth station antenna or the ground station antenna to focus the satellite in order to get the information from the satellite or they receive the information from the satellite. Do you understand this point? So that point, the point at which is located, at which the satellite is located is going to be the sub-satellite point. Is it clear? We have learned in the previous slide. Okay, so I think this information is enough for the latitude and longitudinal calculation. Let's move ahead with the further topics. Okay, so now what happens apart from this latitude longitudinal information, we need to understand the azimuthal calculation and elevation of the antenna for intercepting the satellite. So many of the earth station, that is the satellite antennas, are highly directional in nature. Directional means it will be focused at one particular point. So whereas we have so many types of satellites like geosynchronous satellites, which will be at a fixed position, or geostationary satellites, which will be at a fixed position on the satellite orbit. Okay, it seems as though it is stationary. In that, we'll have the dish antenna fixed. But whereas the other satellites which will be moving, other satellites which are rotating across the Earth's curvature, we need to have the directional antennas to focus the signal. Okay, therefore, we need to focus move the position of the antenna, which are highly directional in the nature, in order to accurately position to hit the satellite. Hit the satellite means direct point of communication should be there between the satellite and the antenna in order to receive the good signal. Okay, so this azimuthal and elevation designations are again represented in degrees where to point the antenna. Okay, so first we have located with respect to the latitude longitudinal information. Apart from that, we need to understand the azimuthal and the elevation for pointing the antenna. So this azimuthal calculation, that is azimuth refers to the direction where north is equal to 0. And this azimuth angle is measured clockwise with respect to the north. The same way, the angle of elevation is the angle between the horizontal plane and the point direction of the antenna. Once this azimuthal and the elevation are known, the earth station antenna can be pointed in that direction. As I told you earlier, for geosynchronous satellites, what happens? The antenna will simply remain in a fixed position. We are not going to move the position of the antenna. So these kind of antennas you could see in petrol bunks. You see, nowadays all the petrol bunks, actually most of us will not get noted, but most of the petrol bunks, they are all communicated or interconnected. If HP is running across the country, and also this Indian Oil, Bharat Petroleum, everywhere you see, they are having their petrol bunks across the country. So everything will be centralized with the help of the satellite communication. Previously, they used to have what is that, LAN connection or some kind of other internet connection. They used to establish wired connections, but nowadays everything is being uniformly centralized. Probably that is when you go once to the petrol bunk, you have a look at that. What is that? There will be a small building and there will be a small dish will be in a fixed position. So they are going to make use of what is that, geostationary satellite, and that the antenna will be fixed and it will keep on receiving the signal, and whatever data they are updating in that location of the petrol bank, it will be updated centrally. Okay, so they have a centralized communication. Okay, so the what is the service provider at one point of location will be able to monitor all the locations sitting at one point. Okay, so for that reason only it is being used. So it is effectively implemented in petrol bunks nowadays. So similarly, we have so many other applications also. And for any other satellite, for other satellites which are not of 24/7 services, the antenna will be moved as the satellite passes the overhead. I told you the other satellites which are located in the LEO and MEO, which does not have the continuous service providing purposes, they will be moving. So whenever it is coming closer to that station antenna, we need to receive the signal. So in that case, the antenna should be moved. Moved means the direction of the antenna should be focused, moved here and there, in order to have the direct point of communication of this antenna feed to the satellite. Okay, so that is how it is calculated. So this is the azimuth calculation and the elevation calculation. So this is an example of this 90-degree azimuth value and elevation of 40-degree. You see, so this is the Earth's that is what is that latitudinal information. It is going to be 0. It is 90-degree, 180-degree, 270, and again it is going to be 360. So this azimuth angle you see, so it is the line that is drawn from the 90-degree towards the 0-degree north. So you have to imagine, so it's going to be a kind of this kind of thing and a vertical 0-degree north. That is going to be the azimuth angle, and the direction of antenna should be located at this position, which is determined by the angle of elevation. This angle of elevation we have already discussed, is it not? So what is the angle of elevation? It is the angle between the, do you remember all those points? Line drawn from the center of the earth to the perpendicular. You remember all those things. So this angle of elevation is for the satellite. So satellite will be placed here, and this, as based on this azimuth angle, the earth station antenna will be placed here. So this is the direction of the antenna. We have to keep focusing the direction of the antenna in this way, at this, that is with respect to the angle of elevation, so that the satellite here will be sending all the signals to the antenna placed here. Okay, so this azimuth and the elevation angle plays an important role in order to have the efficient communication between the satellite and the ground station. Is it clear to everyone? Okay, so now let's move ahead with the further topics like so far. So first case, we understood what are the basic concepts we need to understand in order to launch a satellite. So then orbital information. So now we have launched the satellite, we have placed in the orbit, and all other setups, everything we have done for the satellite to function or provide its service as such. So now we need to establish the communication between the satellites, or we need to make use of the efficiently the satellite's purpose. So how it could be done? By having a good ground station antenna. Therefore, this satellite communication involves two major systems. First one is the satellite subsystem, and the second one is the earth station or the ground station subsystem. So the satellite subsystem, we have launched the satellite. So now it is in the orbit. Okay, so the satellite subsystem means it has so many other, housekeeping or house monitoring systems, which will be helping in functioning of the satellite. Okay, so that involves that is called to be the satellite subsystems. Similarly, we'll have the ground station or that station which is on the earth surface. So that also will be having so many subsystems which will be helping for other systems to function. So now let us see in detail. So again I tell, the satellite communication involves two major systems. First one is the satellite subsystem, and the second one is the earth station or the ground station subsystem. We will see one by one in detail. So the satellite subsystem is the one that is in the satellite, whereas the ground station or earth station subsystem is the one which is on the earth surface. Okay, so our purpose and intention is to establish communication between these two systems, as well as maintain an efficient signal utilization and the extraction of the signals that is being received from the satellites. Is it clear? Okay, so this is one such pictorial representation of how the dish antennas will be placed. And so this, I think you would have learned in your antenna and wave propagation. I think you are learning this semester. So what is this antenna called to be? Sandeep has said it is parabolic antenna. Yes. Anybody else?
Parabolic reflector antenna.
Yes, it is going to be parabolic dish antenna. So what is the center one called to be? Can anyone tell? Are you able to see my cursor? Yes, it is going to be the antenna feed. It is going to be the antenna feed. Okay. So in case of receiving antenna, it is going to be the antenna feed. That is, all the signals from the satellite or any other source will be received, that is going to be fed here, and that will be communicated here. Is it clear? To the other systems here, which is on the ground station or any other system that is going to work on that. So whereas in case of transmitting antenna, it is going to be again the antenna feed. It will be what happens? Collecting all the informations here and it will be transmitting. Normally these parabolic dishes are used for receiving as a receiving antennas. So why this dish is used? Why this shape is used? Can anyone justify? I think you would have learned.
Reflector, ma'am.
Yes, who told? I just who told that? I didn't see who it was. Who it was? Reflector. Who told it was reflector?
Ma'am.
One?
Mohan.
135. Mohan Sai. You are on mute.
Yes, ma'am.
Okay. Yeah. So what is that? Why it is in the shape of dish? What is that?
Used as a reflector, ma'am. Wide range reflector.
Wide range reflector. So it is going to converge or diverge all the signals for better reception. All the signals that is being received and it will be converged and it will be fed to the antenna feed. You understand? Okay. So this is for about the dish antenna, which is going to be the parabolic dish, which is used as the receiving antenna. So now let us get started with the details of the communication satellites. What are the other subsystems? So communication satellites are not originators of information. So they are not going to generate any kind of information. Just they are going to act as a repeater, or they are going to regenerate the signal that they are receiving. Okay, just it will receive signal from one location and it will retransmit to other location. So it is going to act as a mediator. Is it clear? So these communication satellites are not the originators of information to be transmitted, but some satellites also generate their information based on for some other applications they are using. Okay. But most of the satellites that has been launched, they are only going to relay. They are going to act as a relay stations or repeaters. Okay, so the television channels, most of the television channels, they are making use of satellite communication. So what do? There will be the transmitting station or the studio where the television company will be there. They will keep on transmitting the signals to the satellite. This satellite will be acting as a repeater. Just they will receive the signal and retransmit it to the place or broadcast it to the place where it has to be reached. Okay, so if a transmitting station cannot communicate directly with one or more receiving station because of this line of sight restrictions, what happens? Many other repeaters will be used, all other satellites will be used, and also there will be inter-satellite communications. Is it clear? So why this line of sight communication is important means only then the signal strength will be good and there will not be any loss of information. Okay, so this transmitting station sends the information to the satellite, which in turn retransmits to the receiving stations. So this kind of systems which are used for these applications are called to be repeaters. Okay, so this is an important terminology, repeater in satellite communication. So it just repeats the signals, which means that it receives signals from one station and repeats it to this location where it is needed. Okay. So this is one such representation of the communication satellite which does the repeater operation. So you see, so this is the satellite repeater which is going to act as a communication satellite. So this is the transmitting station. So as this transmitting and receiving stations are at different locations, and because of the Earth's curvature, it cannot establish the terrestrial communication. Is it clear? So the point-to-point communication is not possible. Therefore, they make use of this communication satellite as a repeater. So what happens? So it will be transmitting the signal. The transmitting station will transmitting the signal from its station to the communication satellite. So this repeater will just, in most of the cases, it will just repeat the signals without doing any operation. But in some cases, it will do some operation. So such satellites are called to be not repeaters, they are called to be transponders. So it will do some amplification process, it will do some mathematical calculation or some analysis processes will be done. So it is based on the design what we are doing. So such satellites will be called as transponders. We will see one by one. So for now, you understand what a communication satellite repeater does. It just receives the signal from one transmitting station and it repeats the signal to the receiving station. So the frequency at which the signal is transmitted is called to be the uplink frequency, and the receiving frequency is going to be the downlink frequency. Normally we call that as a technically. Okay, so normally the uplink frequency will be at higher frequency. It is going to be 6 gigahertz for satellite communication, and this downlink it is going to be 4 gigahertz. So what is this frequency range? So it is going to be in the microwave frequency range. So normally for all wireless communication purposes, we make use of this microwave frequency ranges. So I think in antenna we have studied. So even though it is hazardous to the human body because it emits a lot of radiation, I think probably yesterday you ma'am might have taken class in antenna communication. So all the subjects, whatever you are learning in this semester are all interrelated. Okay. So you should get some information from this here and there. Okay, so even though it has a lot of negative effects and what is the radiation effects of that, still it is used for the communication purposes. Okay, and so now let us see the differences between the repeaters and transponders. As I told you, the transmitter and receiver combination. So it is going to be, so the transmitter receiver combination in the satellite, it is going to be the transponder. Okay, so it is going to have a transceiver function. So what does a transponder do? The basic function of a transponder is to amplify the signal as well as it's just the frequency translation process. So these are the operations done by a transponder. Whereas in case of a simple repeater, it will just receive the signal and retransmit it. But whereas in transponder, it does some basic operations such as amplification or frequency translation or any other signal processing methods or image processing methods it will do, and it will transmit to the receiving station. So such systems are called to be transponders. So the reason for frequencies translation is that the transponder cannot transmit in the same receiving frequency. You see in this diagram, you see the downlink frequency is going to be different. So if it is going to be in the same frequency, there will be a lot of confusion between the systems which are going to transmit and receive. So always there will be difference between the uplink frequency and the downlink frequency. So that frequency translation is done by the transponders. You understand? So this transmitter signal, strong signal would overload and desensitize so the receiver and block out the very small uplink signal and thereby prohibiting any communication. So always this uplink frequency will be higher than the downlink frequency, and this frequency translation is done by the transponders. Is it clear to everyone? So this is the internal block diagram of a satellite transponder. You see, so this is going to be the receiving antenna. So this transponder will also have the transceiver. Is it not? Both transmitting as well as the receiving antenna. So whatever the signal that is being received. So here in the diagram which we have shown in the previous slide, it was given with the uplink frequency of 6 gigahertz. So that will be fed to a low noise amplifier. So this low noise amplifier will remove all the noises present here whenever it is being received. And what is this block called to be? It is going to be the local oscillator, and that will be mixer. I think probably this kind of circuits you could have learned in your television reception. Is it not? You remember? You remember local oscillator was there even in the first unit, I suppose. Am I right? TV transmitter you might have learned. Is it not? TV transmitter as well as in your telephone also I think you might have learned. There will be an intermediate frequency. Is it clear? So all those same functionality here. So there will be local oscillator here, and that will be mixed with this low noise amplifier signal, and there will be intermediate frequency, and there will be frequency conversion done here. Synthesized frequency synthesizer will convert from 6 gigahertz to 4 gigahertz, and before transmitting the power of the signal has to be amplified. Therefore there will be a power amplifier, and it is transmitted via the transmitting antenna to the ground station where it has to be transmitted. So this is the simple block diagram of a transponder. Do you understand? Okay, So widely spaced, what is that? Transmit and receive frequencies prevent the interference. So the reason for going different transmit and receive frequency is to avoid the interference. Okay, so these transponders are also have a wide bandwidth unit so that they can have the transmit and the receives more than one signal. So when we go for more than one signal, we'll be talking about the multiple access techniques, is it not? So any earth station signal will receive within the receiver's bandwidth will be amplified, translated and retransmitted onto a different frequencies. So this is the functionality of any transponder. So this transponder, what happens? It has a wide bandwidth, and can use one uplink and one downlink signal frequency will be there, and also it will have many number of channels, because when a single satellite is launched, it is not to be set for one's application only. So we need to have so many channels for a good utilization of that particular satellite. Therefore, when we wanted to transmit and receive more than one signals, we will be having different channels. So there will be, there are 20, normal communication satellite will have 24 channels having 12 vertical polarized frequencies and 12 horizontally polarized frequencies. So why this vertical and the horizontal polarized frequencies means, in order to avoid interference. Also, all these electromagnetic waves will be transmitted in the microwave frequency range. Okay, so there will all this should be accommodated within that particular channel bandwidth. So for that, the what is that? The signals will be polarized vertically and horizontally. So when we go in detail the understanding of microwave communication, you will understand all these things. Why it has to be horizontally polarized and why it has to be vertically polarized. Okay, so that we are not going to. That is not our intention here in satellite communication. Just have the information that it can accommodate 24 channels with 12 vertically polarized channels as well as 12 horizontally polarized channels. So within that, we will be able to transmit many signals with the help of the multiple access schemes. So also many of the multiple access schemes we have learned in the first unit itself, is it not? Frequency division multiple access, space division multiple access, time division multiple access. Same methods are used here. Okay, so we are going to learn further in detail. Okay, and this all the satellite communication systems consist of the two basic parts, as I told you. First one is the satellite or the spacecraft, and the second one is the earth stations. So the satellite performs the function of a radio repeater or a relay station. So two or more earth stations may communicate with one another through the satellite rather than directly point-to-point communication on the earth. Okay, so the two or more earth stations, they will be communicating through any other satellite. So as I told you in the first diagram, I have shown you in the previous slide. So, and also we need to know about what would be the size of the satellite. So before going to learn about the detailed subsystems, we will understand what is the size of the satellite, how it is going to be, what is the size and the weight of the satellite normally, general information. So the size, it is going to be 1 feet for a satellite which is launched in the LEO orbit, and more than it could be 20 feet long also, depending upon the application. Okay, and the largest satellite, roughly size of a trailer of an 18-wheeler, so that many wheels you can accommodate. Okay, so that could be the largest satellite you could imagine for high-end applications. And normally the weight of the satellites ranges from 100 lb. What is lb? It is going to be pound. Okay, 100 lb for smaller satellites, and 100 lb means it is approximately 495 kilos. Okay, and or it could be 1000 lbs. Okay, because 1 lb, 1 pound is equal to, I think it is 450 kilograms. Sorry, 450 grams. Okay, 450 grams. So then you have to do the calculation. So this is going to be 100 lb, and the weightest satellite would be the 1000 lbs. So that much large also it could go. So with all these calculations, so finally putting all the systems into the satellite and the spacecraft, we need to wait. Why? We need to design a launch vehicle system in order to lift the satellite. So every factor we need to consider. These are all general information. Okay, so now let us get started with the satellite subsystems. So we all know that the heart of the communication satellite is going to be the communication subsystem. So there will be set of transponders. So what is a transponder? So it is going to have the transmit and the receive system. And it will be, what is that? Doing some amplification process and frequency synthesizing process. And this transponders will receive the signals in the uplink frequency and retransmit the signal to the earth in the downlink frequency. So this transponder, it is going to be a repeater that implements a wideband communication channel that can carry many simultaneous communication transmissions. So these are the satellite subsystems. So this is the next topic. I think probably we can see it in the next class.
Ma'am,
Yes, Ma, can you answer?
ma'am, I have a doubt, ma'am.
Yes, Ma. Teja.
Ma'am,
Mm.
yes, ma'am. In operation satellite, from one end transmitting end, it will take a 6 GHz uplink frequency, no, ma'am.
Yes.
When it is coming to downlink, it takes only 4 GHz. Why, ma'am?
Yes. That's
What
what
is
I told
the
you.
oscillator in that, ma'am? Just it is a reflector, no, ma'am. Transmitting, it will be directly transmit the direct signal, no, ma'am. What is use of
That's
local
what, no. That is what I told you, no. We need to frequency synthesize it because we are how they are transmitting it is in the diagram. I have given a direction like this. From here, it is going here. But in the practically, you think everything will be signal in the form of electromagnetic waves. Only the receiver should tune to that particular frequency. Suppose you see this station, if it is working at the same 6 gigahertz, in case the same 6 gigahertz will directly might come here also, or also there will be some other uplink stations which will be working in 6 gigahertz frequency, but specifically we want this to be received from this particular station. Is it clear? So that only we'll have different uplink and downlink frequency. Also, if you are receiving, what is that? What is that? So transmitting in the same frequency, the same signal will be received by this station itself. It will not go to the other station. So in diagram we have channelized it. So it is going in this direction and it is reflecting in this direction. But we cannot channelize this signal practically. It is not. Is it not? Simply it will be broadcast in the form of electromagnetic waves. Only the receivers should tune to that particular frequency and receive its signals. Okay, practically you think if you are broadcasting or transmitting, you are receiving 6 gigahertz signal, and again if you are transmitting 6 gigahertz signal itself means this antenna, this antenna will have the transceiver part also. The same 6 gigahertz will be received with the same transmitting antenna itself and the station itself, not the transmitting antenna, the receiving antenna present in the earth station. The earth station will have both transmitter and receiver. Transceivers will be there. Understand? For that reason only, always the uplink frequency should be different from the downlink frequency. So I think in the further topics we will learn about the frequency allocation. That time you will understand what is the specific reason for having the uplink and downlink frequency. Teja,
Okay,
is it
ma'am.
clear to you?
Yes, ma'am.
Point. Because we cannot channelize the signal practically. Normally, it will be broadcast. Only the tuner has to tune to that particular frequency and receive the signals. Okay, very good doubt by Teja. So now everyone is clear. Yes, ma.
You
Ritika.
said that uplink frequency and downlink frequency will be deviating. If the case comes that both the frequency are same, so what will happen, ma'am?
That is what I told you now, no, ma. If both are same, it will get confused. So most of the signals will not reach the receiving antenna. It might be receiving the transmitting antenna. That is that same station itself. Do you understand?
Yes, ma'am.
Okay, there will be lot of interference. Okay, for that only you should have. So we'll learn in detail the frequency allocation. That time you will come to know. Okay, okay. So we
Ma'am,
have, yes, ma'am.
for a single satellite, how many signals it can transmit, ma'am, at a time? from different earth stations.
Yeah. Different, there's so many channels. That's it, don't know, 24 channels are there.
Okay, ma'am.
Okay. You can make use of efficient utilization of satellite, you should do it. Okay, ma? We'll see in detail. Okay. So that is what we have learned about azimuthal angle of elevation. Anjali is asking some doubt. Operation of communication satellites, azimuth, latitude, longitudinal satellite repeaters tracking. Okay. Ma'am, actually we not use this camera, but how television gets a signal. See, Anjali has asked, you see, what is the, Anjali, can you unmute and talk to me? Yeah, Anjali, you yourself have answered. We have set-top box. Set-top box means normally if you're not having the direct connection, the set-top box service provider, they will be having the dish antenna in their location. They will be receiving the signals and locally they will be distributing the services. Okay, distributing the signals to the customers. You understand, Anjali? So that is with the help of set-top box. Using bias, yes, that is with the help of set-top box using bias. So normally if you are having the direct Tata Sky connection or Airtel connection or Sun Direct connection or whatever it is, directly you can get from the satellite. If not, you will have to make use of the, what is that, set-top boxes they will be providing. So there will be, that's what the cable providers, cable TV providers, is it clear? So that cable TV providers, they will be having a dish antenna at their place and they will be receiving the signals and they will be having systems to boost up and other things and they will be locally distributing the signals to the consumers. Is it clear? So it is at the places where, at all the locations where we cannot afford this dishes. Is it clear? Okay, ma'am. So as of now, we can wind up the class. Okay, these are the topics we have discussed today. So if there is any data loss, okay, I think this chat box will be stored. Okay, whatever messages you have questioned, we'll discuss in the next class. Okay, I will answer in the next class. Okay, okay, bye now for now.